Cool.
Vendor denotes the communication equipment vendor who made the meter, and there's probably some interesting correlation between are you a large or small company, or are you operating close to Manhattan or further away, that would influence whether you buy vendor one or vendor two equipment. And so that would have an effect on things like how many passengers.
Yeah, right here.
If you're far from the center of the city, then you're more likely to see a family of 4 in your cab.
Yes. So you're saying we left off here, vendor? I'm sharing my screen. Yeah, I definitely remember seeing
a little bit beyond that. That was sort of the penultimate item.
Yeah, I remember seeing distance too. Okay, cool. Yep. Trip duration. Yeah, because if you look at trip duration, store and forward flag. Yeah, so it's a little further than that. Trips per hour. Trip duration. Yeah, that was good. I like this. Speed. Yeah. Okay, so 25 to 65. I remember having that conversation about the highway, and okay. Cool. Store and forward flag. We saw that this was irrelevant. And then total trips per hour. That's where we left off. So it looks like we have only one new person here, Kai. So basically what we're doing is, I don't know if you've ever, I know you work for a big data company. So we went to Kaggle. We found the taxi, the New York City taxi data. We're building a model for the New York City taxi data. And we actually started working through the data set, just like picking it apart here in Visual Studio Code. And we're doing okay. We're kind of just like squirming around because a few of us are newer to machine learning. JH has some pretty good experience. He's definitely the most well-versed in this stuff than any of us. So we were just trying to figure out like what data should we use? How are we going to explore this data? And then Aditya, who's not going to be here tonight, went ahead and shared this guy's notebook that did the same project that we did. And man, he just breaks down the data so well. So the data set that we were given came with, I believe it was like 10 or 11. If you look at the Jupyter notebook, I think we were given, what, like 9? No, we were given more than that. I think we were given 11 attributes, 11 features. And this guy here, what's his name? Nitin G. He expanded the data set out to, I believe, 61 attributes. So just the fact that he was able to handle the data in a really nice way, and he just has tons of experience. He's working with the data in a way that we just weren't. So we're just going through his method for exploring the data, and then we're gonna go ahead and hop back to our exploration of the data and pretty much do what he did. Yeah, and then go from there.
Is this the guy who won the contest originally?
I'm not positive. I don't know.
Well, that would be interesting to. I mean, if there's a guy who did it even better and won the contest, that'd be interesting to see that as well.
True. Yeah, I wonder who won the contest. The guy who won the contest might not have necessarily done it the best, though. He might have just been the first one to do it, and then someone else did it better.
Oh, yeah, that's true. Hey, we could end up being the best one to do it if there's no time limit.
True.
Um,
If we found something that they didn't find, and if we did it differently in a way that created a better model, yes, that's definitely possible, right?
well, like if there's one thing that is a flaw is that considering distance to be between 2 points when that's that's not real distance. When you're stuck on the streets of New York City, um, who knows?
Yeah, I wonder what it would
We,
take
we
for us.
haven't we haven't ex we haven't experimented with the API yet that would give us the real distance. Um, but I'm imagining things, but
True. And distance is only one attribute. So
yeah.
I wonder what it would require for us to create a better model. And I also wonder what the accuracy of this model that we're going through right now is. I'm sure we'll come across that sooner than later. But for now, we'll go ahead and we'll continue just going through this right here. We'll probably just spend the session going through the rest of this. That way, tomorrow we can just start where we left off in our Visual Studio Code. So does anyone want to say anything before we get started?
You
I just
know,
would like to say that I will be just watching. Thank you.
Yeah, that's totally fine. No sweat.
uh, one of the things, before you, I don't know if this is broken up into sections, but I mean, one of the things can just be how do like really get into how do you graph these things? Like, what are the different commands to do the different types of graphs? Because that's like so much of knowing how to do that, like, is huge. Because we tried to run things that took
Yeah.
2 hours and then didn't even give us. Like, I ran one thing and I posted a screenshot of it that took 80 some minutes, and it you know there's a little bit interesting in it because it showed some of the dots were in California or somewhere, but so that's what am I
So,
thinking?
so the rule is simple. If it takes more than a minute and you're surprised, then you're doing the wrong thing and you should just stop it. And at that point, you want to understand what's happening. And often in data science, you want to make a simpler problem for yourself. So here we're presented with 1.5 million rows, which, in some sense is small data, but 1.5 million can be a big number, especially if you are running some algorithm that is on the slow side, or maybe is quadratic or cubic in the number of rows that it processes. And so if you can bring it down to 10,000 rows or even 10 rows, that will at least give you an opportunity to get the syntax right, and you can go through an edit debug cycle, once every few seconds. And after you're confident that you understand what's happening with very small data set, then you can take out your stopwatch and you can crank it up to 10,000 rows, 100,000 rows, 1,000,000 rows. And from those, you should be able to make predictions that it took me half a minute on the 10,000. And so I'm going to make a prediction that it's a linear algorithm in the size of the data frames rows. And so 10x on a half a minute should give me a 5-minute running time. And if your stopwatch says 6 minutes and it hasn't completed yet, you should start getting anxious and think about debugging it a little further so you better understand it.
Yeah, yeah. So you're saying before we even start figuring out which data to explore, expanding the data set from 12 attributes to 61 attributes and all that, just chop the data set to just a small piece and only use that small piece to create our graphs to make sure that we're actually just getting our syntax correct. And then once we have everything laid out the way we want, we're visualizing everything that we want to visualize, then scale it back up to the 1.5 million rows.
Yeah, so you don't have to do that immediately. I was suggesting that you want to do that as soon as you're surprised, as soon as you're bored, as soon as you're wondering, when is this ever going to finish?
Yeah.
At that point, you should confess, oh, I don't understand what's taking so long. Let me scale it down and better understand it. Let me probe this a bit more. And I'll be able to probe it many times in 5 minutes if my edit debug cycle is rapid because there's only a few rows.
Yes. Yeah.
Did this guy say in his report here that he just looked at a sample of 10,000, or are his rows working nicely because he binned everything into things like by the hour and by the 10 to 20 miles and 20 to 30 miles.
I don't remember him saying anything about scaling the data set from 1.5 million rows down to 10,000 rows to make it load faster. I don't remember him saying anything about like trying to make it load faster at all. I just see what he's doing. Yeah.
Yeah, I wonder if you took a new notebook and plopped in his commands, would you get the same thing, or is he leaving out sort of a lot of things, or is that?
I actually plan on doing that. I actually plan on doing that. Like even after we go through his notebook, I want to go ahead and just kind of like write out all the code that he wrote out, just line by line, just to do it, just to get the hands-on experience, just to go through the process. Because now we're just reading through it and kind of like chatting about what he did and why, understanding the thought process behind like why do we even need to show this plot, why do we need to break up the hour from 0 to 24 hours, so we're just working through it and chatting about it right now, but it's still a good idea to actually type it out.
Is his thing here a literal Jupyter notebook, meaning that it has to have the stuff in there, although maybe you can, I think, hide, put things on invisible, I suppose. Or is this literally a, report?
This just looks like a report. Yeah, this just looks like a report.
Things were plopped into.
Yeah, this looks like a report. Because this is on Kaggle.com, so this is his code. I'm sure you might be able to download his code somewhere, though. Copy cell link. Yeah, so you could copy the code if you wanted to. Yep. Yeah. All right, well, let's start working through it. So where we left off was total trips per hour. So let's take a look at the distribution of the pickups across the 24-hour time scale. I believe we chatted about this a little bit so far. So he just did an sns.count plot, data pickup hour. And then he showed the plot, so you're seeing how many trips happen between midnight or midnight to midnight, basically. Looks like most of them are happening around 4 to 8, with just like super busy during the day. It's in line with the general trend of taxi pickups, which starts increasing from 6 a.m., so right about here in the morning, and then declines from late evening around 8 p.m. There's no unusual behavior there. That's all as expected. Total trips per weekday. Let's take a look now at the distribution of taxi pickups across the week. So he is just figuring out what he wants his plot to look like. He's taking the data.weekday number, Sunday through Saturday. Actually, I think it's Monday through Sunday, and then the X label is the month, and the Y label is the pickup counts. Here we can see an increasing trend of taxi pickups starting from Monday till Friday. The trend starts declining from Saturday till Monday, which is normal, where some office-going people like to stay at home for the rest of the weekends. Let's drill down more to see the hour-wise pickup patterns. Oh, this is, I remember exploring this too. Okay, cool. We could keep total trips per month. Let's take a look at the trip distribution across the months to understand if there is any difference in the taxi pickups in different months. So we passed in data.month to SNS, count plot, just gives different labels. So the Y label is the trip counts, number of actual trips. X is the months, and then you could see the number of trips spread across the months where the data set was collected. Quite a balance across the months here. It could have been more equivalent if we wouldn't have removed the inconsistent records in our study of the univariate analysis. What is this? What are the ones? The inconsistent records. I know we did remove some. I won't dwell on it for now. I'm going to go through it again anyways. Bivariate analysis. So does anyone know the difference between a univariate analysis and bivariate analysis? I know someone mentioned it last week.
Well, the uni has got to be one variable, and the bi has to be two. So on the univariate, like, what do the pick out? Well,
So
Yeah,
univariate
maybe-
might be mean, and bivariate might be a correlation.
Okay. Bivariate analysis is used to find out if there's a relationship between two sets of values. It usually involves the variables x and y. So trip duration per hour. We need to aggregate the total trip duration to plot it against the month. The aggregation measure can be anything like sum, mean, median, or mode for the duration. Since we already did the outlier analysis, so we could take the mean to visualize the pattern, which should not result in the bias of the general trend. So you can see he's taking the data, he's grouping it by the pickup hour, so midnight to midnight, and he's finding the mean of the trip duration. So the Y label is the trip duration in seconds, and these bullet points are just the average for this hour. So average trip at 6 a.m. is under 750 seconds. Average trip duration at 3 o'clock is 1100 seconds. Okay, so that makes sense. The average trip duration is lowest at 6 a.m. when there's minimal traffic on the roads, moving faster. Average trip duration is generally highest around 3 p.m. during the busy streets. Trip duration on average is similar during early morning hours, so all these early morning hours before 6 a.m. and late evening hours after 6 p.m. Yeah, so you can see it's kind of, they're all ranging from like 900, 900, all in that area, except for the spikes at 3 and the drops at 6. That makes sense. Trip duration per weekday. So this one was just per hour. Now trip duration per weekday. Let's now analyze the pattern of trip duration during the week. So same thing. He's taking the data. He's grouping by the weekday number. And then he's finding the average of the trip duration. Same thing. You can see Mondays, the average trip duration is 900 seconds. Tuesday, Wednesday, Thursday. Thursdays and Fridays, they seem to be the highest, 980 average. And then Saturday and Sunday are low like Monday. Cool. We can see that trip duration is almost...
Is that, I guess that's not that big of a difference between, I was just looking at Monday and Tuesday and trying to figure it out, but it's not 900 to 960 is not, it's not much of a deal. Okay.
Yeah, about a minute difference. Average. Yeah. We can see that trip duration is almost equally distributed across the week on a scale of 0 to 1,000 minutes, with minimal difference in the duration. Actually, it's not 0 to 1,000 minutes, it's seconds. Also, it is observed that trip duration on Thursday is longest among all days. So Monday, Tuesday, Wednesday, Thursday. Yeah. All right, cool. Trip duration per month. So I know we only had a 6-month period where the data was collected. Let's take a look at the trip duration pattern with respect to the different months. So he took the data, he grouped by month, which is another one of our attributes, and then he found the average trip duration. So actually the trip duration was lower in the first 2 months and highest towards the end. We can see an increasing trend in the average trip duration along with each subsequent month. The duration difference between each month is not much. It's still small. It's still within 2 minutes, basically, 2-minute difference. It has increased gradually over a period of 6 months. It's lowest during February when winter starts declining. There might be some seasonal parameters like wind and rain, which can be a factor of this gradual increase in trip duration over a period. Like May is generally considered as the wettest month in New York City, and which is in line with our visualization, as it generally takes longer on the roads due to traffic jams during rainy seasons, car accidents, probably that sort of thing. So naturally the trip duration would increase towards April, May, June. Yeah, so spring. Trip duration per vendor. We can also look at the average difference between the trip duration for each vendor. However, we do know that vendor 2 has larger share of the market. Let's visualize. So we could group by trip duration based on the vendor. And it looks like vendor 2 is a little bit longer. Vendor 1 is 800 seconds on average. Vendor 2 takes the crown. Average trip duration for vendor 2 is higher than vendor 1 by approximately 200 seconds, at least 3 minutes per trip. I think that's actually kind of big when you think about how big the data set is too, though.
So again, I wouldn't want to impute causality. He's just saying that they're correlated. There's probably some interesting business relationship between large and small taxi firms or the vendors, or what year they started rolling out their product, and that's probably the hidden variable that explains this. It's not like installing a certain meter is going to make your cab go slower.
Yeah, true.
I think in this year, the TLC had not yet figured out that revealing lat longs has serious privacy concerns for the ridership, and so you see in subsequent years that they blind us to the detailed lat long. They just say roughly what part of the city you began and ended in. And also in this year, it appears that the TLC was trying to figure out which is their favorite vendor.
Huh? How do they determine which is their favorite one?
Well, it appears that part of why they invited people to look at the data is they wanted to evaluate the vendors and see if there was reliability issues with one or the other. One of the vendors either does not implement the store and forward flag, or somehow it magically is always in range of a transmitter. And the other vendor, it's got this, tiny fraction of 1% of all trips wind up with the store and forward flag. But I can certainly see that if someone's working for TLC, they'd be trying to evaluate which vendor do we recommend for medallion cab owners.
That makes sense. So trip duration versus flag. Let's visualize if there are any effect of flag setting on the trip duration. So we're just figuring out how we want to make this look. We're taking data. We're taking basically any of the rows in our data set where the trip duration is less than 10,000, I believe. And then we have trip duration on the y-axis and flag y on the x-axis. So what is this actually showing? Trip duration versus flag. So if the flag is yes, how long the trip it actually is, right? Only if the flag is yes. That's what it looks like. And it's only showing trip durations under 10,000 anyways, which makes sense. Okay.
This is the store data flag, or are these the two different companies? Like in the previous graph, they had the two colors, and is that carrying down to this one?
Yeah, so we have vendor 0 and vendor 1, which is like, yeah, 1 and 2, I guess. And then, but this is just the yes flag. So when they did have to store and forward the flag, this is the trip duration for when they did have to store and forward flag. The trip duration scale is less for the trips where the flag is set. The trip details are stored before sending it to the server. Trip duration outliers are also less for the trips with flag Y as compared with the trips with flag no. So there's less outliers, which makes sense because the number of trips with the flag Y are so small in number compared to the trips with no that it's like, obviously the trips with no would have much more outliers. Trip duration is longer for the trips where the flag is not set. Interquartile, I think the number of trips where it was set to yes are like so low too. It was like 0.01 or something super low. Interquartile range of trip duration is more for the trips with the flag Y as compared to the trips with flag no, but the median value is almost equal for both. Interquartile range.
You know, one of the things that just struck me is if the system is trying to connect to the cell tower or however it works, the longer the drive, the more time it has to do it, and we don't know exactly, if you drive longer and then it connects, did it still store? Yeah, if it does it during the trip, is that a store and forward, or is a store and forward when like the whole trip you can't do it, and then like later on after the trip it does it? And what is can you even send that data until you have? I mean, the trip has to sort of be over so you can the end of the trip. So is that?
Yeah,
is
I think
that
it
like
only sends twice. There's just two send events, one at the beginning when the meter's on, and another will retransmit the initial timestamp and location together with the timestamp and the drop-off location.
Okay, so
for example, you might lose connectivity when you go through the Holland Tunnel, but we don't do any drop-offs in the middle of the Holland Tunnel. So if you're at a location where you can drop someone off, typically you have reasonably good radio reception.
Does it become a Y if you missed the first send, but then it works at the second send, at the end of the trip?
I doubt it.
You doubt it? Is it?
Yeah, I think there's an initial send to keep cabbies honest. I mean, New York City has a long and sordid history of people playing with meters so that you get greater fare for the same distance. So I think the initial send is just to keep people honest, and it kind of doesn't matter because it's going to be retransmitted when you click the meter off, and that's when it actually matters. And so it's good from TLC's perspective that only a tiny fraction of these fares are reported in delayed fashion.
Okay. The idea I was trying to suggest is the longer the trip, the less likely it would be a Y because it has the entire trip to connect and something during the trip. But I don't know if I know enough about.
I respectfully disagree. If you look at the outlier distances, sometimes we go very far away from Manhattan, and those I expect would have a greater incidence of the flag being set. For example, sometimes we're in California and there wouldn't be any good reason to provision communication services with the cell towers in San Jose, California, given that the target audience is Manhattan taxis.
So there's those cases too where they're getting so far away from the tower, then that's a reason for it not to be able to do it.
Cool. So next is distance per hour. Let us check how the distance is distributed against different variables. We know that trip distance must be more or less proportional to the trip duration if we ignore general traffic and other stuff on the road. Let's visualize this for each hour now. So from midnight to midnight, basically, grouping by the pickup hour, and then the average distance based on the pickup hour. So it looks like the distance by kilometers traveled per trip is the highest between 4 and 7. I guess you could kind of say like everywhere from midnight to 6. It's kind of got like a flat line and then a spike here, and then it's just like pretty steady distance down here, 3 kilometers to 3.5 kilometers throughout the rest of the day, throughout the busy hours. But it seems like during the slower hours, you're going to get longer trips. When people are taking taxis during these hours, it's less likely that they're taking them to work, right? They're probably taking them somewhere else. And trip distance is highest during early morning hours, which can account for some things like outstation trips taken during the weekends. True. Longer trips towards the city airport, which is located in the outskirts of the city. That makes perfect sense. Trip distance is fairly equal from morning till the evening, varying around 3 to 3.5 kilometers. It starts increasing gradually towards the late night hours, starting from evening till 5 a.m. It decreases steeply toward the morning. Yeah, so he's just so for each one, he's making observations. And I kind of like going through this, and before even going down to the observations, I'm trying to make some observations. I don't know if anyone else wants to make some observations before I actually scroll down and read the observations, but I think it's pretty cool when you make these observations and then you roll down and you see he made the same observations, So just giving it a shot. So next is distance per weekday. Let's analyze the average trip distance covered on each day of the week. So he's grouping by weekday number, so the day of the week, and finding out the distance, the average distance based on the day of the week. Looks like the average distance based on the day of the week is Sunday and Monday. And then from Tuesday to Saturday, it's pretty low. But if you look at it, we're looking at about 3.35 kilometers to 3.7 kilometers average, which isn't a big difference. We're looking at like a 0.35 kilometer difference. So it's pretty tight. Does anyone else want to make any observations before we read his? So it's fairly equal distribution with average distance metric varying around 3.5 kilometers an hour, with Sunday being at the top, maybe due to outstation trips or night trips towards the airport. Distance per month. So now we'll look at the average trip distance. It's grouping by month, finding out the average distance based on the month where the data was collected, and the distance was shorter in the winter months. I believe it was February and March. Then we have like April, May, June, July, and so the distance is increasing as we get to the later months. Though you still look at 3.35 and 3.55, that's still very, very close. Anyone want to make any comments, observations?
Now, my only thought is, if I were doing this, I think I would like to see like two graphs, one with a zero scale, just to show how close they are, and then the one he's got to sort of show the zoom in and show the actual difference. Because when you're not on a zero scale, your eyes can trick you into thinking, well, wow, there's a big difference between one and the other, and when you have the zero scale, you can see, okay, they're nearly the same.
Yeah, you can see that it's very small. Though there's less precision, it's harder to see the actual details of, like, if you're on a scale of like 0 to 10 with something this small, then the graph would have to be larger. Otherwise, like here I can clearly see that this is like 3.37. This is 3.33. This is 3.40. 43
Yeah, I
or
wouldn't get rid of
44.
this.
Keep it. Just have an extra graph.
Yeah, like right next to it, and show that, well, they're all pretty. Maybe if I did it and looked at it, it'd be like, no, this isn't needed. But you know what I'm saying.
Yeah, yeah. Can I ask why the zero scale? What do you get with the zero scale that you don't get with this one?
Well, you see that they end up much closer. You see the height of them. Uh, how do you say it? On the zero scale, you'll see that these are all, and it might be it might be a bar graph, but you'll see they're all bar towers of pretty similar height. When you see the full body of the tower line underneath it, when you zoom into the very edge of the tip of it, you're seeing an exaggeration of the difference more than you would see if you were looking at the entire scale from the number down to 0.
Mm. So you want to?
Yeah, I completely agree. I'd summarize it as the graph author is lying to you.
Often is the case and you need to be on the lookout for that in anything you look at, especially your news newspapers and wherever they give you a graph. If you're not getting the zero scale, um they could be exaggerating something to over
Yeah.
prove a point.
So you want to be able to take a quick glance at the graph and see how small the range really is, basically. Like you.
If these were on a zero scale, it might be, maybe not on this one, but it could be, almost a flat line, which then your takeaway is, there's really not that much of a difference. But if you zoomed in, you could see that, okay, the difference is between, 3 point, whatever the lowest is and the highest is.
Yeah.
Because it's good to know the peak and the bottom, but still, they're not wildly different.
Yeah, they're super close. The range is very small. So here also the distribution is almost equivalent, varying mostly around 3.5 kilometers, with fifth month being the highest in the average distance and second month being the lowest. So he's finding the highest and the lowest. Distance per vendor. So he's grouping by the vendor ID, finding the average distance, and the distance is pretty similar as far as the vendor goes. It's about 3.4, 3.5. This is more or less same picture with both vendors. Nothing more to analyze in this. It's pretty straightforward. Distance versus flag. Let's visualize if there is any effect of flag setting on the distance and the trips. So he's pulling any trip with a distance that's less than 100. And the y-axis is the distance in kilometers. The x-axis is the flag y. And this is distance versus flag. So this is one of these flags yes and one of these flags no? I think, right?
You know, it seems like it's saying where the flag is yes.
That's what it seems. I know that's what it
And
seems
here,
like.
and these
but-
are the two vendors.
Yeah, but it says nothing about the vendors here. It says just distance versus flag. There's nothing about vendors in the code either, so that's why it makes me think. Y, distance, data, plot, distance. Yeah. So we can see almost similar results like the one observed in the trip duration versus flag analysis. Only two major differences can be seen here. Interquartile range of distance is almost twice for flag Y trips as compared to flag. Okay, so yeah, this is flag Y, this is flag no, or N. Yeah, so one is yes, 0 is no. True, false. Median value is much different in both the cases as well, which points us to the fact that range of distance and trip duration for the flag Y trips is much more limited to the confined as compared with the flag N trips, and this also resulted in much less number of outliers for flag Y trips. Yeah, that's clear. Many more outliers here. Distance versus trip duration. Let's visualize the relationship between distance covered and respective trip duration. So we're actually using a scatter plot for this one. We are passing in the trip duration and the distance. Not positive what those are. Feel free to give that a Google or just shout out if you know. X label is distance, or Y label is distance. X label is trip duration. So as the distance increases, or as the duration increases, it looks like the distance increases. Though you do have some down here where it took super long and the distance is still low, so that's curious.
Yeah, that's quite a dark. In that's where he cut off the data. So that's why it's sort of a hard edge you don't go past. But it's still, interesting how there's so much there, and I don't know or at least I have a great understanding of those 24-hour trips. That there's such a good number of.
80,000 seconds. Yeah, that's crazy.
Yeah, maybe I thought that's where the edge was, but maybe maybe that's not 80,000 seconds, but I thought that was where he cut it off at 24 hours.
Well, would you mind flipping over to the chat channel?
Yes.
Chat messages.
Oh, here.
So, I feel that in a sense that display was sort of backwards. When we read a graph, we usually think of the x-axis as being the independent variable, and then the y-axis is determined by x. So, f of x, y equals f of x. And when someone calls up a taxi or an Uber, they have in mind a pickup and drop-off location determining a distance. So the distance is a fixed attribute of the journey, and then the elapsed duration is anyone's guess how long it'll take to get through traffic. So I wind up choosing them in that direction. Also, he was using Matplotlib, which obviously can work fine. I prefer Seaborn because you get these labels for free. So I had dataframe.distance, and that gives the x-axis label of distance. I had dataframe.elapsed, which again gives us the vertical y label. And then we've got OLS, ordinary least squares, is the line through the center of the plot that is sort of showing all the trips above the line were in city traffic, less than an average of 18 miles an hour, and below the line were highway traffic. And then there's like speed of light is an excluded zone where if someone's going faster than 80 miles an hour, it just doesn't show up in the data. So this is just an alternate take on the same data set with anything beyond 4 hours discarded as an outlier.
Copy that. Yeah, so you cut out all that stuff that was over in the 80,000 area, 80,000 second area. Useless.
Yeah, so like the two in the right margin would be airport trips. All highway.
These here. Yep. Cool. Yeah, I like this.
What would you call the top middle?
I find that really interesting. I honestly don't know. Maybe interborough, maybe from Manhattan to Brooklyn. It's like there's a bridge in between that nobody gets off when they're on the bridge.
Huh. That's
A
interesting.
great traffic jam day.
Yeah, 20 kilometers is not short either. Looks
Well,
like
it could be
that.
Manhattan to Brooklyn. Oh, maybe it's going to JFK. Because if you look at the spatial diagram, outside of lower Manhattan, the hotspots that show up are Newark Airport in New Jersey and LaGuardia in Queens. And then there's a ton of traffic going to JFK, which is a bigger airport. If you land in New Jersey, there's a better chance that you take a bus than a taxi. But if you land at JFK, taxi is a perfectly sensible approach.
Yeah. Cool. Yeah, so you basically just took this little chunk right here, right?
That's correct, and flipped it.
Yep.
About the y equals x axis.
Yeah. Cool. So there are lots of trips which are covered negligible distance but clock more than 20,000 seconds in the terms of duration. Initially, there is some proper correlation between the distance covered and the trip duration in the graph, definitely, but later on it all seems uncorrelated. There were a few trips which covered huge distance of approximately 200 kilometers within very less time frame, or a much smaller time frame. Which is unlikely and should be treated as outliers. Let's focus on the graph where area distance. Okay, so that's very similar there. So this is trip duration of just 1,000. Okay. And then distance. So he took all the trips where the distance was less than 50 and the duration was less than 1,000. And then there should have been a linear relationship between the distance covered and trip duration on average, but we can see dense collection of the trips in the lower right corner, which showcase many trips with inconsistent readings, which is, it's got to be, because if the distance is low, but the duration is high, it's got to this has to represent traffic.
Mm-hmm.
Like the fact that New York City is just a high traffic area, and it's amazing
that people will spend 20 minutes in a cab traveling almost no distance before they abandoned. I have to believe that many of those trips ended with an abandon.
That's crazy. I know. I know. And then this is just empty roads, right?
It corresponds to highway speed limit, right?
Yeah. All right. So there should have been a. All right. Read that. We should remove those
And
trips.
this comes back to the 6 a.m. readings that, at 4 o'clock in the morning, you can actually observe the speed limit by looking at what a taxi did. During congested periods, it's going to go way down.
So if you do it at 4 a.m., then you're going to see a much more linear relationship with like all these trips down here disappeared.
Correct.
Yeah, that makes sense.
Yeah, if you filter it, you'll see quite a different graph.
Yeah, so if instead of doing data distance less than 50, trip duration less than 100, and daytime in between like midnight to 6 a.m., it'll probably look,
right.
You'll see the linear relationship much more clearly. That makes sense. Cool. Yeah, that's cool because he does have like these are pretty general visualizations. He kind of did like what you have to do, but I could see how you could break it down to an even more granular level than he did. My question is like, where do you draw the line? Like, where do you stop chopping it up and making it more and more granular? And how beneficial is it if you even do that, Like, you have to draw the line somewhere, otherwise you'll just drown yourself in like irrelevant data that's not. And how do you know what is the relevant data? I have so many questions.
Well, we've been discussing various aspects of the business domain, right? That traffic is different when the sun is down, that airports matter, trips to airports tend to be longer. And so you need a question to focus you. Often there's someone from the business looking over your shoulder that has a couple of urgent questions and would be happy to get an answer to even just one of them. And so you keep drilling down on slices of the data that matter to the business. For example, maybe you're worried about staffing, how many people should be on the next shift driving taxis around. And you could ask that generally, how do I staff over the week? But you could also focus very specifically on, I have drivers from a garage in the Bronx, and I'm worried about a shift that starts at 4 in the morning. And so you might look at a different slice of data for that narrowly focused business question than you would if someone's just saying, oh, well, I'm curious about this data set.
Yeah, so you have to let the business mission and goals kind of guide which data you're even diving into. Huh. Yeah, that makes sense.
You guys just listen to me eat a cookie.
I couldn't even hear it.
Okay, good.
Yeah, you're good.
The question: have you tried clicking that copy and edit? Because as you said it, I wondered if on the copy and edit version you could actually, put in what you were talking about. You were talking about, adding if you scroll up a line, if you were saying add in and data hour is equal to 6 or something, and then you would see just you'd see more of a line and less of the bottom corner of that data. I was wondering if would that work? And is that
Yeah, it looks like it opens up an active notebook.
Well, I think that'll be interesting.
Yeah,
okay, so yeah.
You can do that.
So there's
we'll have to run
all
of these to go down there though. So we'll just skip that for now. Feel free to find that code though and give us a snapshot of what that looks like. just so we could keep pushing through this. All right. So if you do type that in though, Sweeper, definitely share it because I'm curious to see it. I would like to see the relationship. We should remove those trips which cover 0 kilometer distance but clocked more than 1 minute to make our data more consistent for a predictive model, because if the trip was canceled after booking, then that should not have taken more than a minute time. This is the assumption. So if the data equals 0 and the duration is greater than a minute, and this just means remove it. Now, instead of looking at each and every trip, we should approximate and try to filter those trips which cover less than 1 kilometer distance but clocked more than an hour. True. Well, it is New York. So take the distance that is less than or equal to 1 and a duration that is greater than or equal to an hour, and distance, trip duration, so duo. And you can see trip duration, wow, distance. And so what's this line here then? And what's this blue shading? Huh. Let me see. Data, locate. Okay, so this is just going to be all the trips that are less than 1 but greater than an hour. Okay. Okay. So from 0 distance to 1 kilometer, and from 0 seconds to 80,000 seconds. So these ones are the only and greater than an hour, right? So this is 1 hour. This starts at 1 hour, and this is everything greater than 1 hour. So that means these are all 1 hour, even though they're only a kilometer. Yeah, that's, even still, a kilometer should never take an hour.
How are you getting the 0 line to be an hour?
Because he takes only the data that is greater than an hour. So that means anything that starts at 0.
Okay.
That starts at
greater
an hour.
than or equal to an hour.
Yeah, so this is 1 hour to 80,000 seconds. Yeah, so this is all impossible data though, right? Like there's no way it could be less than. But that's why I'm wondering, like, what is this line? It looks like it represents the linear relationship. Let's see. Though the straight line tries to show some linear relation between the two, but there seems to be negligible correlation between these two metrics as seen from the scatter plot, where it should have been a linear distribution. Yeah, so all of the rows are on the top and on the bottom. There's only a few actually in the middle, but for some reason it's still showing a linear relationship. It is rarely occurs that customer keeps sitting in the taxi for more than an hour and it does not travel for even 1 kilometer. True. These should be removed to bring in more consistency to our results. So all of these data should be removed. So
the blue line is what it should be.
This blue line is the relationship. It's a linear relationship, but clearly it shows a linear relationship, but clearly it's not linear.
I thought it's like what he added, like he plotted the point, but he also added, like, this is what he expected within like the margin of the light blue, and instead he got, at least That's what I thought I was reading here. He's like, the correlation between these. Maybe I'm misunderstanding his text. So if anybody else can um, has any idea.
So
I,
EDA is exploratory data analysis, and a big part of EDA is cleaning. In the course of doing discovery, you inevitably find dirty data. And so one of the artifacts that we've seen is all these trips that are near the 86,400 second cutoff. And this is just highlighting that fitting a linear model to bimodal junk data is not sensible. And the thing to do is to discard the junk, to discard anything that's more than a few hours.
So the diagonal line is not what the data is. It's the added guideline of what you expected, and just to illustrate how much so that it does not follow it, right?
Oh no, that line is correct. It is minimizing an error metric. OLS, ordinary least square, is minimizing the square of the residuals. And in order to do that, it was sort of attracted to the lower right because for points on the bottom, there's more of them I said that badly, in the lower left. Points on the bottom, there's more of them on the left, and so that's attracting the line in that direction. And conversely, up top in the upper right, there's more points in the right than the left. And so the OLS had a fool's errand to go on, and it did the best it could.
Okay, that made it clear to me. I wish it was in a different color, so that it was not like these are the point, like these are actual points that ended up in the straight line. But I get how you said it made it clear.
Yeah, well, if the data was accurate, then they would be following this line, but you just see the heavy collection at the bottom left and a heavy collection at the top right. So that's showing a line that it's just like I don't know the technical terminology for it, but the line is accurate, but the it's misrepresenting the data. I don't even know if it's misrepresenting the data because it's representing the data correctly, but we won't dwell.
The data points are what they are. They're divorced from reality, but once they're in your data frame, then OLS does the right thing with the data frame.
Mm-hmm. So we go ahead and cut all these out, basically. Interesting. Average speed per hour. Let's look at the average speed of New York City taxi per hour. So we group by pickup hour, and we find the average speed per hour from midnight to midnight, basically. It looks like the speed increases from after midnight until about 4 or 5 a.m. And then the speed that they're moving at decreases from about 5 a.m. until 8 a.m. Obviously, it's getting busier and busier, moving towards rush hour, and then throughout the day, you're just constantly moving slow. I've experienced that before. I know what it's like. I hate it, but it's the reality. And then from 6 p.m. until about the morning.
So this is a classic case where showing the origin would make it easier to visually interpret this graph. The fact that we've omitted 0 miles per hour makes this harder to interpret.
True, right? Because we're starting at 12 kilometers per hour. Why would he cut off from 0 to 12 then? Do you have any idea what would be the purpose of that? Why would he do it like this?
Yeah, so first, pardon me, I should have said kph, not miles an hour. And second, it's just defaults that it makes sense for a graphing package to come up with automatic Y limit. and it's responsible as the author to do the right thing. Sometimes this would be an appropriate graph to display, but in this context, with these numbers, showing 0 would have been better, and the author could have done that.
So this is just default unless you specify otherwise. Okay.
Right.
It's always great to see the close detail, but then that's why I think it's great to see it in both side by side. Yeah, here's the far out view. Here's the extreme close up.
Yeah, we should do that when we actually go through and do this project. Like when we circle back to our Visual Studio Code and start building all these stuff ourselves, we should definitely explore those too, just for a less misrepresented visual. So the observation. Go ahead.
I was gonna like the real world example is like you look at a flat surface and it's flat. If you zoomed in it with like a microscope, it would be extremely jagged, and things would look totally opposite, but it's the same thing. That's an interesting way to think about it.
Yeah, that makes sense. So the average trend is totally in line with the normal circumstances. Average speed tend to increase after late evening and continues to increase gradually till the late early morning hours. Average taxi speed is highest at 5 a.m. in the morning. Then it declines steeply as the office hours approach. Average taxi speed is more or less same during office hours, 8 to 6 in the evening. Makes total sense. Average speed per weekday. So we are grouping by the weekday, and we're finding the average speed. So you can see Monday, the speed is a little bit faster than the rest of the week. Then Tuesday through Friday is pretty steady. And then it increases Saturday and Sunday. The roads are probably a little bit less busy. But even still, we're 13.5 to 16.5. So when you look at that, like 13.5 kilometers an hour versus 16.5 kilometers per hour, it's pretty close. So average speed is higher on weekend as compared to the weekdays, which is obvious when there's mostly rush of office goers and business owners. Even on Monday, the average taxi speed is shown higher, which is quite surprising when it is one of the most busiest day after the weekend. There could be several possibilities for such behavior. A lot of customers who come back from outstation in early hours of Monday before 6 a.m. to attend office on time. So coming from the airport, lots of highway trips. That makes sense. Early morning hour customers who come from airports after vacation to attend office business on time for the coming week. There could be some more reasons as well, which only a local must be aware of. We also can't deny the anomalies in the data set, which is quite cumbersome to spot in such a large data set. Passenger count per vendor. So let's try some different metric in the series. Passenger count, we will plot it against the vendor only because it will not be much helpful to plot it against hour, weekday, or month like others, as the passenger count should be a whole number and not a ratio. We will take the mean as the aggregate measure because we already did the outlier analysis on this metric. So our results wouldn't be affected by some extreme values. Also, if we take median, then it will return only 1 because majority of the trips have been taken by a single passenger. Let's take a look about its distribution. So grouping by vendor ID and seeing the average passenger count per vendor. So the average passenger count is about 1.25 for vendor 1 and 2 for vendor 2. Clear difference between the two operators for the average passenger count in all trips. It seems that vendor 2 generally consists of 2 passengers as compared with vendor 1 with 1 passenger. Let's bifurcate it further. So this is grouping by passenger count. Same thing with vendor 1 and vendor 2. All right, so it's actually breaking these down into the actual number of passengers. passenger count, vendor ID count. Okay, so there's going to be 3 here. So blue is vendor 1, orange is vendor 2, and then, yeah, so vendor 1 has more 1 passenger trips, and then vendor 2 is higher for all the rest of the trips. And I don't see vendor 1 with anyone with 5 or 6. Vendor 1 only has 1, 2, and 3. It seems that most of the big cars are served by vendor 2, including minivans, because other than passenger 1, 2, vendor 2. Other than passenger 1, vendor 2 has majority in serving more than 1 passenger count, and that explains its greater share of the market. Yeah, so they have bigger vehicles. That makes sense. Map visualization. Cool. This is the stuff I like. We shall visualize the taxi pickup locations by placing long and lat marker on the map of the U.S. so that we can analyze below questions. Are all pickups constrained to New York City and its surrounding areas? Is there any unusual location of the pickup? Are the latitude, longitude constrained to the land area of the U.S. and nowhere else? So base map. We'll utilize the matplotlib base map tool. So this is basically just creating a map marker for each latitude and longitude pickup. Draw boundary, coastlines, fill continents. All right. Cool. Map marker data. This is small. I wish he didn't cut it out. I wish he showed like the whole thing, including the ocean, because I'm sure we'd see some like red. Yeah, I see a red dot in California. That's probably why he...
So again, this is automatically choosing the map scale based on the longitude.
Yeah, okay. Okay, that makes sense. He could have expanded it though. We'll expand it later though. One unusual pickup from California. This is the one you mentioned, JH. There are quite a few pickup from the neighboring state as well. Some are quite far and some very near to New York City. Yeah, I could see some even down here, like north of Delaware. We should check the validity of the unusual pickup here and take corrective actions if necessary. Let's take a closer look. Wow, so he actually dials in just to that one in California, huh? We can see that through the trip duration is approximately 8 minutes. Still, the distance traveled is just in a few meters. Moreover, the latitude and longitude readings are same. That is a black swan and should be removed for the inconsistency of the model. Let's remove it now. Alright, so just removing the minimum longitude. Yeah, so the one furthest south, basically. Okay. So we can see that through the trip duration is, okay. Let's check whether those have been removed from the map or not. Interesting, fine. We can still see the marker in California. Were there more than one pickup in California or the data is still not filtered? Let's check again. So this one is a different pickup, but with the same story like the previous one. Trip duration is not in correlation with the distance covered. Let's remove this one as well and call up the map marker to check the latest picture. All right, so now after removing those two from California, it looks like most of the trips are in New York. We do have some that are pretty far out there. Pretty far. One in the ocean. A couple here in the ocean. That's funny. But most of them, yes. Right in Manhattan. Jersey. Long Island. There are quite a few pickups being shown off the New York City coast in the Atlantic Ocean. Now, most of the pickups are being shown in and around New York City. It would be cumbersome to track them and remove. We can ignore them as of now to focus more on New York City pickups. New York City pickup locations. He's drawn another map. Let's focus on the New York City area. And for that, we have to fix the longitude and latitude to view only the New York City area map. So he's doing that here. Wow, it actually like shows the streets too when you visualize it like this. Clearly this is a busy road. Wow. That's cool. Yeah, in most
What did he choose to what limits did he place to make it? Did he pick certain latitudes and longitudes to exclude? Okay.
Set the limits of the map.
Yes, there's a bounding box.
Yeah.
Okay.
So a lat min, lat max, long min. Yep. So we could see most of the taxi pickups were done in the Manhattan area as compared to other areas in New York City. A long trail towards the airport shows that the airport is situated quite far from the Manhattan area. So this is the airport, I'm guessing.
So there's 3 airports depicted here. You just showed us JFK. There's also LaGuardia to the north.
Right here.
Yeah. And to the far west, we have Newark.
Here.
And what's kind of interesting about Newark is that TLC rates apply to the 5 boroughs. I don't know, maybe there's some special arrangement that they have with Newark, but clearly New Jersey's outside the boroughs.
Yes, definitely. Wow. Yeah, I can see.
So he didn't strictly set the lat-lon boundaries to New York City. Unless that's the.
No, there's definitely
is this
New
still the pickup,
Jersey's.
or-
New Jersey's definitely in here. You just can't see it because there's not enough trips.
I guess where did he?
That's correct. This is still pickup. And, you know, there's lots of drop-offs at Newark, and I can understand that a cabbie would want to do a pickup at Newark as well.
Mm-hmm. True. So there must have been some long-distance rides towards and from the airport. Similarly, the average duration for the rides picked up to or for the airport would have been longer. Yes. So now drop-offs. So he's doing the same thing. He is creating the constraints of the map. And then, wow, okay. So same thing. You can see the airports too. And you start to see the shape of New Jersey as well.
Yeah, you can even see Staten Island.
Where's that? Right here?
So presumably that's people. No. That's Brooklyn. To the west is Staten Island.
Oh, here.
That's no. That's New Jersey. Now you're getting warm. There you go.
Here.
That's Staten Island.
Okay.
If you look at a map, it seems obvious that Staten Island should be part of New Jersey, but it's a 5th borough.
And you can't
It's
see it.
very interesting.
True.
Well, there's no pickups there.
Yeah.
So there's a pickup elsewhere, and someone says, apparently, take me across the Verrazano Narrows Bridge. I assume that very few taxis go on the ferry.
True.
So I imagine that Manhattan taxis do not wind up in Staten Island. I imagine it's mostly Brooklyn taxis that do that. And I also find it very interesting that the Bronx clearly has a lot of transportation demand, but there's almost no yellow cabbies that are circulating in the Bronx. So if someone wants to be picked up in the north, they probably will call up a gypsy cab service that's not a yellow medallion cab. But on the other hand, if you've spent all day in Manhattan and you want to go home to the Bronx, you probably just hail a yellow cab and say, take me home to the Bronx or to southern Brooklyn.
True.
Yeah, notice there's almost no activity in the Bronx, almost nothing in southern Brooklyn.
Oh, yeah. Wow. Yeah, you're right. But there are a lot of drop-offs. Not a lot, but more, for sure. Huh. Yeah, that makes sense. That's interesting. Cool. Alright, so though the drop-offs seem to be larger in number than the pickups, but we know that for each pickup we have associated drop-offs in the data set. It's just that the pickups were majorly concentrated in the Manhattan area. Yeah, and the drop-offs. So it looks like most people are being picked up from Manhattan, and just there's way more drop-offs in the surrounding areas. Oh yeah, mostly Queens and Brooklyn. Cool. All right, it's about 7:28 right now, so I'm gonna say we stop right here at the feature engineering, and then hopefully we can finish this up tomorrow.
One last idea.
Yes.
It's almost like the the law of physics where help me out here. The particles sort of like disperse from a concentration to a I'm forgetting the exact word, but you have a concentration and it spreads out into a. I'll think of a better way to say it, but when you look at here's where the pickups, and then they branch out to all the places people want to go. It's almost like particles going from a concentration to a solution or.
Do you think the pickup and drop offs are more spread out over a larger area in the summer versus in the winter where air condenses?
Well, that could be a whole nother graph here. It's interesting to think about. Is like the taxi cab wants to be in the place where he's going to be most likely to pick up a fare, and then but he may take the person out into the middle of nowhere, but he's not going to sit around in the middle of nowhere waiting to find another fare.
No, I don't even want to go to the middle of nowhere, because then I'd have to drive all the way back before I pick up another fare.
Yeah.
Unless the money was really worth it. But I don't know. I don't know how it is. That makes sense, though. Yeah, so this is like a whole nother section right here of feature engineering. So we basically wrapped up our data exploration today. And then, yeah, feature engineering. This is like, after looking at the data set from different perspectives, let's prepare our data set before training our model. Since our data set do not contain very large number of dimensions, we will first try to use feature selection instead of feature extraction technique. All right, cool. Yeah, and we'll start from there. Cool.
Great meeting.
There's still a lot of dimensions to me, but I guess that's not a lot for data scientists. So, cool. Alrighty, I will. Actually, I'll be with my lady all day tomorrow, but I'll definitely be popping into the meeting too. She'll be hanging out with me as we do this. Cool. Enjoy your night, everybody. I will chat with you all soon. Thanks for coming.
Night.
Night.